Hello viewers, in today's session we are going to discuss another important problem from derivatives, and here we are going to find out the derivative of this function y, that is the sum of two inverse trigonometric functions. So here we have sine inverse x plus sine inverse square root of 1 minus x square, where x belongs to this open interval 0 to 1, and we have to find the derivative of y with respect to x at this point, that is x is equal to 1 over square root of 3, right? So let us see how we can find out the derivative of this function y with respect to x using the method of substitution, and then applying the concept of inverse trigonometric functions. So let us start. So now let us simplify this function by making this substitution, that is x is equal to sine theta. So here we'll substitute x is equal to sine theta, and when we take x is equal to sine theta, then this function takes the form that is sine inverse sine theta, and then we have here sine inverse square root of 1 minus sine square theta. So now we can write y is equal to sine inverse sine theta, and here we have square root of 1 minus sine square theta. So we have sine inverse, and we have square root of cos square theta, because cos square theta is equal to 1 minus sine square theta. And then we have sine inverse sine theta, and here we have sine inverse, and square root of cos square theta is simply a cos theta, right? So now we have to here simplify this expression containing theta by using this condition. So here we are given that x belonging to the open interval 0 comma 1. So x is greater than 0 but less than 1. Now here we have taken x is equal to sine theta. So this implies that sine theta is greater than 0 but less than 1. So now let us quickly see the graph of sine theta, right? So here we have the angle theta, and here we have the values of sine theta. So here we have pi by 2, here we have pi, this is 3 pi by 2, and here we have 2 pi, and here we have plus 1, and here we have minus 1. So now see here sine theta is greater than 0 but less than 1, right? And here we have 0, and here we have 1. So when sine theta lies between 0 and 1, that is 0 and 1. So when sine theta lies between 0 and 1, then theta, it lies between 0 and pi by 2, right? So now we have this inequality. When sine theta lies between 0 and 1, then theta lies between 0 and pi by 2. So now let us consider one property of inverse trigonometric functions, and we know that sine inverse of sine theta is equal to theta when this theta, it lies in the interval that is from minus pi by 2 to pi by 2. So that is here we have minus pi by 2, and here we have pi by 2, this is 0. Now from this inequality theta lies between 0 and pi by 2, that is from 0 and pi by 2. Here 0 and pi by 2 are not included, right? So this interval, that is 0 comma pi by 2, is a subset of this interval, that is from minus pi by 2 to pi by 2, right? So here we have sine inverse of sine theta, and our theta it lies in the interval that is from minus pi by 2 to pi by 2. And from this inequality, we can also say that theta lies in this interval. So here, due to this property, sine inverse sine theta is simply theta, right? So now let us consider this term. So here we have sine inverse, and here we have the cosine function. So let us try to convert this cosine function into a sine function, right? So we can now write here sine pi by 2 minus theta, right? So here sine pi by 2 minus theta is cosine theta, and now we can here write theta plus pi by 2 minus theta only when pi by 2 minus theta it lies in this interval, right? So let us verify that this angle, suppose pi by 2 minus theta is equal to alpha, then we have sine inverse of sine alpha, and we can now write theta plus alpha only when this angle alpha it belongs to the interval that is minus pi by 2 to pi by 2. So let us verify that this angle alpha it belongs to this interval. So now let us start with this inequality. So here we have theta greater than 0 less than pi by 2, and here we have alpha is equal to pi by 2 minus theta, right? So let us multiply this inequality throughout by minus 1, so that we can have this negative theta. So we have here 0, and the direction of the inequality get reversed. So here we have minus theta, and here we have minus pi by 2. So now here we have plus pi by 2. So let us add plus pi by 2 throughout this inequality. So we have 0 plus pi by 2, and then we have pi by 2 minus theta, and here we have minus pi by 2 plus pi by 2. So this is pi by 2, and pi by 2 minus theta. We have already taken this angle as alpha. So let us write here alpha, and here we have 0. These two terms get cancelled, right? So we have now alpha greater than 0 but less than pi by 2, or for alpha we can write pi by 2 minus theta is greater than 0 but less than pi by 2. So now this angle, that is pi by 2 minus theta, that is alpha, it lies in the interval that is 0 to pi by 2, and again this interval is a subset of this interval. So this angle pi by 2 minus theta, it belongs to this interval. So here due to this property, that is sine inverse sine theta is equal to theta, we can now write sine inverse of sine alpha as alpha. So now we have here theta plus alpha is pi by 2 minus theta. So theta and theta get cancelled. So we have y is equal to pi by 2. So now here we see that our function y is simplified to this function, that is y is equal to pi by 2, and this is of the form, say y is equal to k, right? And now if we differentiate both sides with respect to x, then dy over dx is equal to d by dx of pi by 2, and pi by 2 being a constant, the derivative of a constant is 0. So here we have 0, and here we can see that y is equal to pi by 2 is independent of x, right? So the derivative, that is dy over dx, is equal to 0. So now we have to find the derivative at this point. X is equal to 1 over square root of 3. So the derivative, that is dy over dx at x is equal to 1 over root 3, is also equal to 0, because dy by dx is equal to 0, and it doesn't contain x.